Hi, my name is Ben. I'm the production manager for Syvecs, and today we're going to be talking about direct fits, such as this guy, and moving on to sort of ECU end kind of thing. How do these work? Why do we use them? What is the methodology behind them? The main reason we use direct fit or direct fit PCBs or distro plates or whatever you want to call them, there's loads of different names, is ease of use. The general purpose of these things is quite simply to help with production. Building things, building full looms can take up quite a substantial amount of time for anybody that's aware of what goes into them. For example, this is for an LP560, LP570 Gallardo, and we use two of these as the car has two ECUs. And the idea behind this is to take the OEM header, which would be the standard ECU, which would obviously be in place of this here, and use a PCB inside to draw all of the circuitry to exactly where it needs to be and output it or input it, which way you want to look at it, into each one of the connectors, making it very easy to work with, one in the field and also in-house. How do we do that? So I'm just going to grab another PCB so you can actually see what one of these looks like inside. Here we have the PCB that is actually inside of it. As you can see, there's lots of wires for the super seal connectors, as well as the OEM ME9 header. We also, to make it a little bit more variable with different kits that we can use this one PCB for a series of kits, depending on how the solder bridges are set inside. One other takeaway from this as well is that some kits do require that you have flyback diodes for, say for instance, power up, main relay, all that kind of thing, and they are actually on the board already. So it saves us having to wire in a relay and diodes into the loom. What you end up with is something like this. So it's very simple. Each of the wires mirrors the other plug. So for instance, pin 1 would go to pin 1 on the opposing side. There's no joins, it's very straightforward, it's clean, it's very simple, and you can work with it quite well without any problems. It simplifies the kit to a point where if there is a problem, it's very obvious. So if one of these wires breaks, you're just looking straight. You're looking straight for this wire, and it's very unlikely you're going to break the loom, but it takes away some of the complications which can result in some damage or errors or something like that. Anything can happen with cars. This particular one is for McLaren 720S, and this is where it gets a little bit more complicated, and we started to be a bit more smart with how we use these boards, and not just using them for simple PCB work with routing and joins and whatnot. So now, as I mentioned, this is the 720 distribution board or direct fit board. This one, the guys engineered in what is essentially an I/O expander. We wanted to use the S7 Plus. The diversification of that particular ECU is very wide. However, it didn't have enough I/O to be able to handle what's involved with the 720S. So we decided that it'd be a good idea to put most of the I/O on the board. You end up with essentially a kit which would otherwise need to be on, for example, an S12 like the Lamborghinis, now ending up with a much simpler kit, and obviously driving the price down, which some of you may know is much cheaper than a Lambo kit. So that is, in a nutshell, why we use these particular boards. And we have since then sort of moved into different areas of Syvecs of where we can use those, implement them, and make better use of them to help with production and simplifying the kits for you guys. So the next thing we have is one portion of a four-wheel drive or Howdex controller. It takes the X4, and it in a way it takes the board that is already used with a super seal header, and we can use something like this to draw out all the tracks inside and use the OEM pins and effectively marry this up to the board. So it creates a direct fit capability which would otherwise need a loom, and the earlier versions of this kit did have a loom, and now it's much simpler, and it is genuinely direct plug and play. So I'm just going to grab the unit so you can have a look and see how this works. This is the 8V2 or RS3 TTRS Mark III Howdex controller, which is mounted on the rear diff of the car, or very close to it. And as you can see, obviously, as I was showing you before, this piece, if I take that off, we've just got two sealing parts here, rubber seals. You can now see how this has been mounted to the board and is being used to utilize the direct fit, making this a much nicer kit for people to use. So it's just, that's another way of why this can be used and be much nicer than a conventional loom. It's much easier to build. It's less likely to go wrong. Overall, I think you probably agree, it ends up being a much nicer and simpler product. So that's that part. And I'm going to move on to the last part of how we would use something like this. This is a bit of a hybrid. That is the YARIS Kit, which I know is on the internet taking a storm at the moment with everybody fitting them to their new YARIS GRs. It is a hybrid between one of these guys. So it removes the complexity of building a loom for the car, and it routes all of the joins and everything like that, or the wiring for the car directly onto the board. What makes this different is that this would be a conventional slave or master and slave configuration. What we do is we mount this onto an S8, it is soldered directly to it, and it hits two birds with one stone, essentially. It acts as a slave. It also acts as a direct fit and completely removes the need for a loom altogether. So, which makes that kit very nice. And I'm sure you've probably seen on our socials that we have quite a few YARISes at the moment which are using this, and customers seem to be loving them. So I wish they could all be like that. It's not always possible. It can be quite difficult to seal much older connectors and all that kind of thing. So it's we do this where we can. It's a bit sparing at the moment, but we hope to do it a bit more in the future. That was a video on how we use direct fit PCBs or distribution PCBs. If you have any questions, please let us know in the comments below. Consider subscribing, and if you want to hit the bell icon and the like button, that would be brilliant, and we'll catch you in the next one.